Alright, 35. This is an involved problem. This is the largest proof on this exam. So let's just go ahead and get started and read it. It says, in the diagram of parallelogram ABCD below, here are the things you know, in addition to this being a parallelogram. You know that BE is perpendicular to CED. So this side here, BE is perpendicular to side CED. So that means that there is a right angle here, a 90-degree angle. You also know that DF is perpendicular to side BFC. So DF, this side here, is perpendicular to side BFC. So there's also a 90-degree angle here. Okay? And then the last thing they tell you is that side CE. Side CE, this side right here, that's going to be congruent to side CF, to this side here, to side CF. What they want you to accomplish is to prove that ABCD is a rhombus. They want you to prove that this parallelogram, the whole entire thing, is a rhombus. So you need to know, what are the options open to me for proving a rhombus? And these are your options. The first thing you must do is show that this thing is a parallelogram, which luckily they give you. They tell you that. That's the most involved. Or that is involved. And then once you've accomplished that, which that we did, you have to do one of these two things. You have to show me that this parallelogram's diagonals, that they're perpendicular. And that's the trap. They give you these perpendicular statements, but a lot of people will say, oh, this is a diagonal problem. As you can see in the diagram, no diagonals are drawn in. So we're not going to use that method. We're going to do a very common method, which is to show that two adjacent or consecutive sides are congruent. And given how this looks, I got a lot of business going on up here and over here. The sides that we're going to show are congruent. It's going to be this side here, okay, and this side here, from B all the way to C. I have an idea as to what I'm doing and how I'm going to do it. I need to prove this is a rhombus, so my goal is to somehow get this side to be congruent to this side. That's what I need to do. Because if I can do that, then I can say this thing is a rhombus. Well, how will I do that? If you look carefully enough, you have two right triangles. There's going to be like one on the top and one on the right side. The one on the top is going to be this. Here's the third side, right? This blue side here. You've got a right triangle right there, and you can kind of pull that out. See how that's a right triangle? I know there's a lot of pieces to it, but I'm going to rotate it and redraw it. So I'm going to redraw it like up here. I'm going to make the blue side stand up. That's B to E. The green side is on the bottom. Okay, that's C. And then that red side is now right here. And what I know about that triangle is, well, there's a right angle down at E. Okay. Um, no, sorry about that. There is a right angle down at E. And I also know that this side will be congruent to something else. So that's the first triangle. That was the top one. Excuse me. Then there's this other right triangle. which the third side is right here. So you can kind of see that triangle there. I could pull that out, and I could like spin it around, and what happens is this triangle is actually congruent to this one. But you have to kind of provide an explanation, a rationale. So let me redraw that other triangle, and I'm going to orient it the same way. I'm going to put the blue right over here, and that blue goes from F to D, right? D is at the top, F is at the bottom. So that the green side, F to C, right, C, that's down here, and I know that's going to be congruent to this one, okay? And then my third side, DC, DC is right there. And if I take this information, hey, there's a right angle at F, a right angle at F, and I got that congruent side. So far, we've got an angle, a side, congruent to an angle, and a side. To prove triangles are congruent, right? Triangles are congruent. We've got side, 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 angle, 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 side. I'm going to stop right there. We're looking like angle, side, angle, side. It'd be great if we could get that angle C to be congruent to, hey, this is weird. Angle C congruent to angle C? That's interesting. Look in the diagram they give you. This angle that C in the top and the right triangle, it's the same angle. All right, that angle C, when we put it into the triangle, this first triangle, it's right there, and it's also in my other triangle. It's the same angle in two different triangles. It gets double dipped. It gets used twice, and that was we learned the reflexive property. When something's shared between two objects, that thing that's being shared, in this case an angle, it's very flexible. It's used in two objects. So we can say that this angle C is congruent to this angle C by the reflexive property. And that gives us angle side angle, which now unlocks that these triangles are congruent. And that's the secret to this problem. Now that I've got congruent triangles, well, obviously this red side from one of my triangles must be congruent to the corresponding red side in the congruent triangle. Because, look, if I've got congruent triangles, then the corresponding parts also have to be congruent. And that's a buzzword, CPCTC. Corresponding parts of congruent triangles must be congruent. And that's how I'm going to end the proof. That's what gets me that those two adjacent sides are congruent, and then if I pair that with the given, that's how I'm going to show this is a rhombus. So we've kind of walked through how to do this. We know how to solve it. Now we actually got to write it up. We got to prove it. That's why I'm saying this is kind of involved. So let's go ahead and make our statement reason. Statement reason. And with all of these proofs, you're going to list all of the givens. So they give us a ton of givens. So I'm just going to list them all. I'm going to say A, B, C, D is a parallelogram. Okay, that's one thing they give us. They give us these perpendicular statements. They say BE is perpendicular to CD. Boom. They tell us DF is perpendicular to BFC. And then they say CE is congruent to CF. CE is congruent to CF. Just make sure. Yep. All right. So I've stated all the givens. How am I allowed to say all of these things? Well, you gave it to me. It was given. The next thing we did, so when we say all those given things, that gives us this side, right? There is the congruent side piece. Now we need to get one of our angles. And I'm going to focus on these right angles. So the second thing I'm going to say is that angle BEC. Angle BEC has to be congruent to angle DFC. Right? Well, how did I know that? Well, they're both right angles. All right. Well, how did I know they're right angles? So we can say the thing we're given, the perpendicular lines, we can say perpendicular lines form right angles which are congruent. So boom, that gives us an angle, this gives us a side. Now all we have to do is say that angle C is congruent to angle C. So I can say 3. Angle C is congruent to angle C. Why am I allowed to say that? That's the reflexive property. Okay? And there you go. We've now got enough information for angle, side, angle. So we can say that those triangles, BEC, so I'm going to have triangle BEC, so when I scroll down I can see, is congruent to triangle DFC. Okay, so the fourth thing I'm going to say is my triangle congruent statement. Triangle BEC is congruent to triangle DFC. Why am I allowed to say that? It's simply, let me remind myself, that's the angle, side, angle postulate. That's my reason. Angle, side, angle. Okay. Well, now that I've got those congruent triangles, I'm now allowed to say that BC, this side, right? So I'm just writing this down. You don't need to do this piece here. It's because I'm scrolling, I can't see the diagram that I have. DC. So I can now say that these sides have to be congruent because they're corresponding parts of congruent triangles. So therefore they must be congruent. And that was the whole entire point of me saying I've got these triangles that are congruent. It's so that I can say, well, they're corresponding sides, BC and side DC. Those things have to be congruent. And my reason for saying that is corresponding parts of congruent triangles are congruent. And that's fine. You can just say CPCTC. So now that I've said that, now I've got my two adjacent congruent sides, and I've got my parallelogram. All right, I needed to show it's a parallelogram that was achieved in the given, and I needed to show two adjacent sides are congruent, and that was achieved right there. Now I'm allowed to actually say, oh, that thing you wanted me to prove is a rhombus is a rhombus. So I can say 6 ABCD is a rhombus. And your reason is a parallelogram, because that's what ABCD is, a parallelogram with consecutive. I like to use that language. It just means adjacent, one then the next. With consecutive congruent sides is a rhombus. And that's it. We've proved it. We just invoked our definition, all right, with consecutive sides that are congruent. All right, you could have written it as a parallelogram with two adjacent congruent sides is a rhombus. So that proof is involved. To practice it, you should really think about these involved proofs as first showing that triangles are congruent, and then using CPCTC to get what you need. The only way you're going to get better at these proofs is simply by attempting more of them. So when we practice more Regents exams, flip to the end of the book, like questions 30 to 36, and look for an in-depth proof, and give it a shot. All right, see you in the next one.